Okay, well, it's been a while since I've been on here doing any assignments, so I'll see if I can reconstitute that habit with starting with this section. Okay. Use derivatives to determine which of the functions below is the antiderivative of that thing, 56x e to the 7x squared. Okay. That essentially is telling you to go through all the answer choices and take the derivative. If any of them wind up being this, then that was the antiderivative. Okay. Super. That's kind of a hard antiderivative to think of, so I guess I really am stuck here having to take derivatives of each of these. Now, they all have the plus c, so and c is just a constant. You're going to differentiate that constant, it's going to be gone. So forget about it. Take the derivative of this, well, that's a product rule, right? So the 4 I can just write down outside of everything, and then the derivative of x, which is 1. Okay, so that's the derivative of the first times the second plus the derivative of the second times the first. Well, the times the first is right there, and then the derivative of e to the 7x squared I'm going to put right here in those parentheses. So the derivative of e to the 7x squared is 14x e to the 7x squared. That doesn't look like it gets it done, right? Because here I have an x squared term, and that's not part of what I'm trying to get. I'm trying to get 56 blah blah blah. So back to the drawing board. This one can't be it. Wow, what a long problem. Let's see if I can whip through some of these other ones. 8 e to the 7x squared. Let's take a derivative of that. Well, here's my 8, and then right here will be the derivative of 7x squared, and then it's e to the 7x squared. Derivative of 7x squared is 14x. 8 times 14, way bigger than 56. So this isn't it. Well, I think I see what we need to do. Or, I can see the answer is going to be the last one, 4 e to the 7x squared plus a constant. Take the derivative of that, and you would have 4 times 14x e to the 7x squared. 4 times 14, sure enough, that's 56x e to the 7x squared. Okay, great. So by process of elimination, that one's got to be the answer. Evaluate the following indefinite integral. So we want to integrate, excuse me, we want to integrate term by term of a minus 4x to the 6 plus 2x to the 5th minus 3x cubed plus 3 with respect to x. And so we just use our the property that this x to the 6th has antiderivative of 1/7 x to the 7th. So because if I took the derivative of that, 7 would come down and cancel with the 7 in the denominator, and the new exponent would be a 6. And I'll just continue this right all the way across. There's my antiderivative. I guess clean it up a little bit, and I would have minus 4/7 x to the 7th plus 1/3 x to the 6th minus 3/4 x to the 4th plus not much cleaning up to do. That's pretty much everything. And there it is typed in. Wonderful. Use properties of the indefinite interval to express the following integral in terms of simpler intervals. Oh, gosh. All they're wanting you to realize is that constants come out front and you integrate term by term. How many choices do you need here? The integral in question is minus 2x squared plus 6x minus 6. So you can integrate term by term. And I'm breaking protocol here and not writing my dx, and I really should. Some of you may say, well, what is the dx? The dx is actually a vector. Whatever that means to you. Alright, so there's me integrating term by term, and then constants can come out front. And look what we have. We have this. Is that it? Yeah. Oh no! Did I just pick the wrong one? That's what I had written down. Is that not what I clicked? Minus 2 integral x squared dx plus... Oh, this one doesn't have the stupid 6 out front. God. How picky. Whatever. I wrote it down right. Just didn't pick the right answer choice. Okay. Lesson learned. I'm tired. It's probably one problem, but that's where my mistake was. Evaluate integral 6x to the 6th plus 3x to the 5th plus 5x minus 4. Okay, integrate term by term. 6/7 x to the 7th plus 3/6 x to the 6th plus 5 halves x squared minus, not equals, what is this about? Minus 4x plus a constant. There's my evaluation. Simplify the 3/6 and you will have this. use properties of the indefinite interval to express the following interval in terms of the simplest integrals. Well, that's easy. I said it was easy a minute ago and then got it wrong. And here we are again with all the answer choices, but it's 6 integral x squared dx minus 8 integral x dx. Is that it? Be careful. There we go. Use derivatives to determine which of the functions below is the antiderivative of this thing. I'm feeling like it's this one. Let me check that. So 7x natural log of 3x, we want the derivative. So here's my the derivative of 7x is 7 times the natural log of 3x plus 7x over x, you just get 7. Then that is not the right one. I was mistaken. Okay. So let me try a different one. 7x squared natural log 3x, we want the derivative. Then I would have 14x natural log of 3x plus 7x. Is that right? Yeah. As you can see. Alright, cool. And these are antiderivatives. 36% mastery. Use derivatives to determine which of the functions below is the antiderivative of 2 to the x. It's right there. Pretty sure, right? Because that is 2 to the x times this constant. Really, to me, it's saying that you have this constant times 2 to the x. And if I took the derivative of this, you have your constant, but then you have the derivative of 2 to the x, which is 2 to the x natural log of 2. You just get 2 to the x. So that one's not so bad. Which of the function, find which function is the antiderivative of this thing. Okay. Well, how about this guy? Minus 5 e to the 3x. If you took the derivative, you would have minus 5 times 3 e to the 3x. And that's exactly what we wanted. And so that problem is finished. One of 4 objectives completed. What else could they have in store for us? Use properties of indefinite integrals. Oh, this stuff again. So it's -6 integral x squared dx. Okay. And then +4 integral x dx. And that's it. Same thing here. There we go. Okay. Evaluate the indefinite integral. No sweat. It's integral -6x to the 6th minus 4x to the 5th plus 5x minus 3 dx. Just keep all your constants. These all have x terms. This one's just gonna, this has an x term, right? X to the 0. So add 1 to 0, and you'd have 1, and it'd be divided by 1. This one has an exponent of 1, so I'm going to divide by 2, exponent 2. This one has an exponent of 5, so I'm going to divide by 5 exponent, or excuse me, it has an exponent of 5, so I'm going to divide by 6, exponent 6. And this one has an exponent of 6, so I'm going to divide by 7, exponent 7, and there we are. I guess simplify the -4/6. Don't write all this extra decorative 1s. That's just there for your edification. Evaluate the following integral. And you ought to be able to do these in your sleep, because the antiderivative rule is so painfully obvious. How is this really any different than what we just did? Feels like deja vu. And this is divided by 7x to the 7th. This will be 6 over 5x to the 5th plus 3 over 4x to the 4th plus 6 over 1 x to the 1 plus c. And that's all there is to it. Yay, 3 of 4. What happened to the second objective? I don't know. What is the particular solution for this guy? Okay, well, this is where, when you do antiderivatives, the plus c gets pinned down as a particular constant. So we know that y prime is a -2 e to the x minus 3x squared plus x minus 4. And we know that y0 is 1. So if I were to just integrate both sides, then I would have the function y. So y is equal to this antiderivative. So minus 2 e to the x minus 3 over 3 x cubed plus 1/2 x squared minus 4x plus c. And we don't know what that c is yet, but this y is now a function of x, and you know that y of 0 is 1. So that would have to equate to being minus 2 plus c equal to 1. Then c is 3. Okay, so then you can write down your antiderivative with that 3 instead of a c, and that's the particular solution. Well, they're not going to stump us twice on that. Here's another one. Y prime is 5e to the x plus 9x squared minus 7x. Okay, so integrate both sides. Then you can get a function of x whose name is y. It would be 5e to the x plus 9/3 x cubed minus 7/2 x squared plus a constant. And you know that y of 0 is 9, but y of 0, you put a 0 in everywhere for x, it just says 5 plus c. So then c has got to be equal to 4, and you can write down then the antiderivative with the 4 instead of a c. And hopefully we are done soon with these. Y prime is minus 2e to the x minus 6x cubed plus 4x plus 3, and y of 0 is 7. Okay, so integrate both sides, you're going to get a function of x whose name is y. This would be minus 6 over 4 x to the 4th plus 4 over 2x squared plus 3x plus c. And of course those fractions will simplify, but I don't even need them to simplify to figure out what c is, because y of 0 is 7, and that would mean that it's a minus 2 plus c equal to 7. So then c is 9, and I will just simplify those numbers upon typing them in. And there we go, you can see my 9, and my hard work is paying off. Oh boy, maybe this is the last one. I wonder if I could do this in my head. So I know when I integrate both sides, I'm gonna have a 7e to the x. Nah, I'm not gonna do it in my head. Y prime is 7e to the x plus 8x cubed plus 9x squared plus 1. So y of x is 7e to the x plus 8 over 4x to the 4th plus 9 over 3x cubed plus x plus c. Of course, this becomes 2, this becomes 3, And y of 0 is 2. That means that 7 plus c is 2. So then c is minus 5. And now we have our particular solution. All right. And awesome. We're done. See you around.